All right, grade 12s, as promised, here's another run through of question 17. So in question 17, they tell us that the graph of function y is equal to 2x squared plus x plus 1 undergoes a transformation. It's going to be stretched vertically, so a vertical expansion by 2, a factor of 2, a horizontal compression by a factor of 1/3. It's going to get shifted to the right 2, and it's going to get shifted down 4. Okay, so those are the things that are going to happen. But we're not used to working with this form. So let's change that. Well, at least let's look at it from a different perspective. Recall that so far we've worked with y is equal to a times f of b times x minus h plus k. If we want to move over the pieces that are related to the y component, like the a and the k, so I want to take this guy over and we're going to take this guy over, we can do that by subtracting k from both sides. So y minus k is equal to a times f of b times x minus h. And we can divide both sides by a, or multiply by 1 over a, to get 1 over a times y minus k is equal to f of b times x minus h. So I trust that you can see that this and this are the same. They've just been manipulated to move some variables over to the left-hand side, but they do exactly the same thing. They just look different. Okay. So let's go back to this then, to the left-hand side here. If we're looking at a vertical expansion by a factor of 2, that means we've got an a value of 2. If we're looking at a translation down, that means we've got a k value of -4. If we're looking for a translation to the right, we've got an h value of 2. And if we're looking at a horizontal compression by a third, we've got a b value of 3. All right, so let's see how that affects things. If I look over here, sorry about that, if I look over here, then 1 over a means my y value is going to get multiplied by 1 over 2. So my y coordinate on my original function is going to look like 1/2 y in my new function. My b value of 3 fits over here, so whatever my x value was, it's going to get multiplied by 3. So I'm going to get 3x. For the translations, my k value is going to be -4, so y minus -4 is going to go to y minus -4 or y plus 4. And for the translation aspect, the x value is going to go x minus h. And if my h value is 2, I'm going to get x minus 2. Okay, so what we're going to do is we're going to work with these values first, plug them into our equation, simplify it, clean it up, and then we're going to plug these values in afterwards. So y is going to become 1/2 y is equal to 2 times x is become 2 times 3x squared. So 2 times 3x squared plus x, which becomes plus 3x, and then plus 1. So if I clean all that up and get y by itself, we replace the x with 3x and the y with 1/2 y. So we get 1/2 y is equal to 2 times 3x squared plus 3x plus 1. The 3x, let me highlight that, the 3x squared becomes 9x squared inside the bracket, and 2 times 9x squared becomes 18x squared. Now if I go ahead and multiply everything by 2, I get y is equal to 36x squared plus 6x plus 2. Now we can deal with the translations. Now we can take these into account. My y becomes y plus 4, and each of my x's become x minus 2. So over here, I get y plus 4 And over here I get 36 times x minus 2 squared plus 6 times x minus 2 plus 2. And if I want to subtract the 4 from both sides to get y by itself, I end up with y is equal to 36 x minus 2 squared plus 6 times x minus 2 minus 2. And I believe that's what we find at the back of the book. So I'm going to go over this again. I'm just going to scroll back to the top and run through it one more time, just sort of pointing at things and maybe using a different highlighter color to highlight. So the first thing to recognize, I guess, is that this form of the equation, of the function that we use to identify our transformations, can be transformed itself. I can bring everything that's related to the y-coordinate over to the left-hand side and keep everything that's related to the x-coordinate together on the right-hand side. So I subtracted k from both sides to get rid of it, and then I divided both sides by a, or multiplied by the reciprocal to get all the y-related values on the left and all the x-related values on the right. That allows me to see how the a value affects y in a vertical expansion or compression. Second, we recognized here that for vertical expansion by 2, our a value is going to be 2. Or horizontal compression by a third, our b value is going to be 3. If there's a translation down, our k value, I don't think I wrote that, our k value is going to be, let me write that here, -4. And for a translation to the right 2, our h value is going to be 2. So that means if my a value is 2, then a vertical expansion by a factor of 2 is going to look like 1 over 2 times y. A horizontal compression by a factor of 1/3 is going to look like b value 3 times x. A translation down where k is -4, translation down where k is -4 is going to look like y minus -k, or y plus k. And a translation to the right where h is 2 is going to look like x minus h, or x minus 2. So once we've got those in place, we deal with the horizontal and vertical expansions first. So my y becomes 1/2 y. My x's become 3x's. We clean that up and get to this stage. Next, we deal with the translations. The translations were y plus 4 and x minus 2. So I replace my y with y plus 4, and I replace my x's with x minus 2. Clean it up again. So I looked at the back of the book and recognized they didn't actually do anything with the x minus 2's, they just left them there. But they did take the plus 4 and subtracted 4 from both sides. So 2 minus 4 gave me the -2. And that was the final result.